Slopes of lines. Hopefully you remember what a slope is from algebra. Okay. Slope is denoted with the letter M. It's kind of how steep the line is. So we use the letter M in our formula instead of writing out the whole word slope. And one way to calculate the slope is to take the two y values and your two endpoints, or points on the line, subtract them, and then divide them by the two x values, or coordinates, that have been subtracted. Okay, you can also think of it as the change in your y value divided by the change in your x. So if you're going from 2 to 4 on the y-axis, you've changed it 2 spaces. If you go from 3 to 6 on the x-axis, you've changed it 3 spaces. So that slope would be 2/3. Okay, and you also probably remember calling it rise over run. So 3 different ways we can think of slope. They all get you to the same place. So let's work some examples here using those different processes. So find the slope of this line. Okay, several different ways that we can do this. Let me get my pen working. We can either use a formula or we can count spaces since we're on the coordinate grid. It's easy to just count. Oh, I'm having a time with this pen. Okay, pen, there we go. So we can choose any points we want to, but it's always good to choose points that are actually on the crosshairs of our grid. Again, it doesn't matter which one we start with. I'm going to start down here. I usually start on the left side and work my way to the right. So if I want to do rise over run, I need to count how many spaces it takes me to get from this point up to the same level as our second point here. So I'm going up 1. We're counting spaces. 1 space, 2, 3, 4, 5, 6, 7. So it's going to be 7 over, now we're going to run. So that gets us to right here. How many spaces do we have to run to get to that point? 1, 2, 3, 4, 5, 6, 7, 8. So if we use the rise over run method, we get 7/8. Rise over run. Okay. If we use our formula y2 minus y1 over x2 minus x1, we just plug in our values. Again, I use this as my first point and then this one as my second point. So this is going to be x1 right here. And because this point is x1, then this has to also be y1. So this is x2 and this is y2. So now we plug it in. y2 is the y value of my second point, which is 2. From that, I'm going to subtract the y value of my first point, which is -5. Don't forget that you are subtracting here and you still have a -5. You need both of those negative signs in there. Don't take this negative right here as your subtraction sign. It's not. Now we subtract our x's. Again, we got to go back to our second point. So x2 is 6. And we're going to subtract from that our x1 value, which is a -2. So once again, we should have 2 negative signs here. What happens when you have 2 negatives? They make a positive. Both cases become positive. So what is 2 plus 5? And what is 6 plus 2? Either way, we get 7/8 as our slope for this line. couple of postulates that go along with this concept. If I have two non-vertical lines, what is vertical? Vertical means straight up and down. So I have two that are not vertical, so they're slanted some way. If they have the same slope, which means they are slanted the same amount, then they are parallel. Two non-vertical lines having the same slope are going to be parallel. Two non-vertical lines that are perpendicular, okay, perpendicular meaning, whoops, that wasn't very good. Just make it all slanted. It means they come together at a right angle, remember. A hard time making these straight. And you get the idea, they have to come to a right angle. Their slopes are what we call negative reciprocals or opposite reciprocal. What is a reciprocal? Think back to algebra. What did you do to the fraction to make a reciprocal? You flip it. Negative in this case just means opposite. We're taking the opposite sign. So if it started off negative, it becomes positive. If it started off positive, it becomes negative. So 3 and negative 1/3 are opposite reciprocals. Remember, a 3 can be turned into a fraction. Any whole number can be turned into a fraction by putting it over 1. So if I want the negative or opposite of that, it would be negative 3 over 1. And then I have to flip it. That's what reciprocal means. So it becomes negative 1 over 3. So 3 is where we started. To get the slope of the perpendicular line to that, I flip it and change the sign. Okay, so again, slopes of parallel and perpendicular lines. Parallel lines have equal slope. So in an equation, it would look like this. Remember your y equals mx plus b. Y equals mx plus b. Y equals mx plus b. So all we care about is the m values because that's what slope is. They are the same in both of these lines, therefore these lines are parallel. So all we have to do is get it in y equals mx plus b, look at that slope, and that'll tell us if they're parallel or not. Perpendicular lines have opposite reciprocal slopes. So again, if we get it in y equals mx plus b, this isn't showing up very well. It's hard to see here. This is a negative 1 over 5. Okay. Then we have, again, we're going to look, dadgum, we're going to look at our slopes. Remember, this can be 5 over 1. So if I flip it, I get 1 over 5. But the signs have to be opposite. So this one needs to be negative if this one's positive in order for our lines to be perpendicular to each other. 4 different types of slopes that a line can have. If they're straight up and down, which is a vertical line, then we say it has an undefined slope. It would be undefined because the bottom of our fraction, our rise over run, okay, let's think about this. If we're doing rise over run as our definition, if I'm starting from, say, this point to this point, I'm rising, but am I running any? Do I go left or right at all? No. So the bottom number 0. Well, you should have learned in past classes that you cannot have a 0 on the bottom of a fraction. That creates an undefined situation. So it doesn't have a number. It's undefined. Horizontal line has a slope of 0. Why? Again, if we define the slope as rise over run, here's one dot, maybe. Here's another dot. Dang. Okay, did I rise any? Did I go up and down at all to get from first point to the second point? No. So that's a 0 as my rise. And then no matter what number I put down here, I could put a 5 and that's still going to equal 0. I could put a 10 and that's still going to equal 0. I could put a -3, that's still going to equal 0. So anytime you have a horizontal line, your slope is going to be 0. If we start from left and go right in our looking, and our arrow or our line goes upward, then we have a positive slope. So up to the right is a positive slope. Down to the right is a negative slope. So if you know these 4 patterns, you can catch a lot of careless mistakes when you're calculating slope. If you make a mathematical error and you get a negative slope, but your line is going up, you should realize that you made a mistake and go back and check your work. And then if you have a vertical line or horizontal line, you shouldn't even have to do any calculations. You should immediately know undefined, 0, because it is always that way. So here's some things to remember. Read the line from left to right. So again, we're going left to right. Is it going up or is it going down? Is it going straight across? If it is going up, it is positive. If it is going down, it is negative. Horizontal lines have a slope of 0 every time. And the equation is just y equals wherever it crosses that y-axis. Whatever number it's crossing that y-axis. Okay, here's the y. If I drew this line, whatever number it's crossing here, that's going to be your equation. Y equals that line. Vertical lines have no slope, or we say it's undefined. Its equation is x equals wherever it crosses the x-axis. So here's our coordinate grid. If I have a a vertical line, wherever it crosses that x-axis there, we just say x equals 4, or x equals 3, x equals -2, whatever. Okay, so let's see if we can figure out some information here. We need to determine if FG and HJ are parallel, perpendicular, or neither. Well, what do we know about parallel lines and perpendicular lines that might help us determine the answer to this question? We know that parallel lines have same slope. Perpendicular lines have opposite reciprocal slopes. So if we found the slope of these two lines, we could compare them and see what kind of lines they might be. So if we're doing line FG, then I need to use endpoints F and G. So I'm going to use y2 minus y1 over x2 minus x1. And I'm going to plug it in. My y2 comes from the second point, so that's -1, minus the y value from my first point, -3. Notice I have 2 negative signs there. Go back to my x values, -2 minus my first x is 1. Now do the math. I need to make these positive. -1 plus 3 is 2. -2 minus 1 is -3. Watch your algebra there. Careless mistakes a lot from misadding and subtracting these numbers. Now let's do line HJ. We're going to follow this same formula. So my second y value is 3 minus my first y value 0 over x2 6 minus x1 is 5. Do the math. 3 minus 0 is 3. 6 minus 5 is 1. Are these opposite reciprocals? They are opposite in that this one's negative and this one's positive. Yes, 3's on the bottom here, 3's on the top here, which kind of makes it look like they flipped, except that 2 is on the top here and 1 is on the bottom here. So it doesn't fit the perpendicular pattern. They're not the same, so it doesn't fit the parallel pattern. Therefore, we should say that they are neither. Okay, let's look at this one on a graph. Graph the line that contains r at 2, negative 2, and is parallel to OP, which goes through 1, 6, and negative 3, 1. So all we have to do is look at each one of these situations and see if it meets all of these requirements. So here, is r at 2, negative 1? Yes. Is O at 1, 6? 1, 2, 3, 4, 5, 6. Yes. Is P at negative 3? 1, 2, 3, 1. Yes. So it appears that this one meets the situation. But let's double check just to make sure. R is at 2, negative 1. Nope. R is not at 2, negative 1. That would be down here. So this one doesn't work. 2, negative 1. Yep. Do these two lines look parallel? Absolutely not. No way. So the correct answer would be A. So be able to use your formula or the idea of rise over run, not just to calculate slope, but to be able to compare slopes of different lines to determine if they are parallel, perpendicular, or neither.